Good evening, this is Kavipriya, Assistant Professor, EC Department. Today I am going to deliver a topic, errors in measurement system. So, while measuring any quantity using a measurement system, there are three types of errors that are being encountered. First one is gross, second one is random, and third one is systematic errors. So, gross errors are human-made errors. So, they are taken into account mainly due to the human oversight and other mistakes while taking reading and recording the reading. So the most common human error in measurement falls under this is the most common human error in measurement that falls under the category of measurement. So the example for this type of gross errors are, for example, if a person taking the reading from a meter, he may misread 23 as 28. So how to avoid this gross errors? So gross errors can be avoided by taking two suitable measures. First one is that proper care should be taken in reading and recording the data, and also the calculation of error should also be done accurately. Second one is that by increasing a number of experimenters, we can reduce the gross errors. If each experimenter takes different readings at different points, then by taking the average of more readings, we can reduce the gross errors. And second is a random error. As the name implies, the reasons for the random errors are random. It is unknown actually. So random errors are errors which occur irregularly and they are random. So they can also arise due to the random and unpredictable fluctuations in the experimental conditions. Example, unpredictable fluctuations in temperature. It can be due to the voltage supply fluctuation or mechanical vibrations of experimental setups. So the errors by the observer taking the readings also comes under the random errors. So reasons for the random errors are random. For example, when a person repeats the same observation, he may likely get different readings every time. So these are all comes under the random error. Next is a systematic error. Systematic errors can be classified into three types: environmental, observational and instrumental. Environmental. This type of error arises in the measurement due to effect of external conditions on the measurement. The external condition can include temperature, pressure, humidity, and even it can include external magnetic field. For example, if you want to measure a temperature under the armpits, and if the electricity goes out and the room gets hot, it will affect the body temperature and at the same time it affects the reading. So this comes under the environmental error. And next is the observational error. These are the errors that arises due to the individual's bias, lack of proper setting of the apparatus, or an individual's carelessness in taking the observations. So the measurement errors also include wrong readings due to parallax errors. And next is the instrumental errors. These errors arises due to the faulty construction and calibration of the measuring instruments. Such errors arises due to the hysteresis of the equipment or due to the friction. Lots of time the equipment being used is faulty due to the misuse or neglect, which changes the reading of the equipment. The zero error is a very common type of error. This error is common in devices like vernier calipers and screw gauges. The zero error can be either positive or negative. Sometimes the scale readings are worn off, which also lead to the bad reading. And environmental or instrumentation errors can take place due to the inherent constraint of devices, due to the misuse of apparatus, effect of loading, and different measures of the errors includes absolute errors, percentage errors, and relative errors. Absolute error is a difference between the measured value of the quantity and its actual value. So it is a variation between the actual value and the measured value. It is given by absolute error is VA minus VE. VA is the actual value and VE is a measured value. Next one is a percent error. It is another way of expressing the error in a measurement. So this calculation allows us to gauge how accurate a measured value is with respect to the true value. So percent error is given by the formula. Percent error is equal to VA minus VE by VE. So VA minus VE is nothing but it is an absolute error. So absolute error divided by the measured value of quantity into 100. Next is a relative error. So ratio of absolute error to the accepted measurement gives a relative error. So the relative error is given by the formula. Relative error is equal to absolute error given actual value. So that's all about the various errors that occurs while taking a reading using a particular measurement system. Thank you.